Okay, first of all, you always kind of want to write out the equivalencies. Okay, so B to the A equals C is the same as saying log base B of C equals A. And the way you can be sure that you have it right is if your variable is in the exponent up here, this is going to get it out of the exponent, because the thing with the exponent, or I'm sorry, if your variable is up here, this gets it out of the exponent to where you can do algebra work, okay? And similarly, if your variable was inside the log, this form would get it out where you can operate on it, okay? So that's a big deal. All right, so 5 to the 3x minus 4 equals 8. Well, your 3x minus 4 is going to be your A, and your 8 is going to be your C. So if you write it in this form, that would be log base B of C. Well, C is the thing that isn't in the exponent, right? That's your 8. And that's going to equal the exponent. And of course, it's log base 5 of 8. B is 5 obviously here, and B will be 5 down here. So that, let's write it with the or the variable on the left. You get 3x minus 4 equals this, and 3x equals log base 5 of 8 plus 4. So x equals log base 5 of 8 plus 4 divided by 3. And then you go to your calculator. Okay. For this problem, your variable stuck inside your log. You're going to use this form, which will get that expression out of the log, right? So we have B is 4. It's usually almost always easy to identify. We're translating it. We get 4 to the second equals 5x minus 1. Just got to be careful to translate it. It's really helpful to write these two equivalences down. Okay. Well, that gives us 5x minus 1 equals 16. So 5x equals 17. So x is 17 fifths. These equations are really pretty easy to solve. Now, if we have an equation like 30 times 5 to the 2x plus 3 was 100. This equation is not in this form or this form, because there's nothing in front of your b to the a here, whereas there's something in front of your 5 to the 2x plus 3. And there's nothing in front of the log base b. So you can't use this just yet, but if you divide both sides by 30, you'll be able to. This means that the 5 for the 2x plus 3 is 100 over 30. Okay, so if you've got a coefficient out in front here, you got to divide through. And at this point, you just proceed to translate it to logarithmic form and so on. And I think you know that because it seems like you had problems of that nature in your homework. And people did pretty well in the homework. Okay. Okay. Now I need to keep myself on track here because the topics in the assignments aren't in exactly the order I would naturally use. Nothing wrong with the order they're in. Probably something wrong with the order I naturally use. Okay, just walking around, looking at what you got. About half of you remember the rule or something very similar to it. About half of you don't remember the rule. And the other half of you half remember the rule. Of course, that doesn't make any sense at all. Okay. Your rule is if you have a log minus a log, then you're going to do log of the quotient. Now I wrote down the rule before. It was, you know, log of A minus a log of B is a log of A over B. Okay. And whatever way your text represents it, it says the same thing. So that shouldn't be a big source of confusion. So you get this equals 3. Now some of you have multiplied this, possibly because you're sitting a ways away and didn't notice that was a minus sign, and that's okay. It's a good problem with a plus. And if you did that, that's good. Okay, but it's a minus, so we're actually getting this equation. Then we translate this. Your base is 2, so we're going to get 2. The thing trapped in your log is going to be over on the other side of the equation. And the thing you got on the other side is going to be your exponent. So using those rules, which you'll get used to, people don't have too much trouble applying those rules with a little bit of practice. And I think most of you have the practice, most of you did well this time. Okay, so we have this. So that x plus 4 over x minus 7 equals 8, 2 to the third being 8. Okay. Now, how do we solve that equation? If you've got denominators, you multiply both sides by the product of all your denominators, or by a common denominator. Preferably the least common denominator. Okay, so multiply x minus 7. I'll do x minus 7 over 1 times x plus 4 over x minus 7. And we see that we could as well write this as x minus 7 over x minus 7 times x plus 4 over 1. X minus 7 divided by x minus 7 is 1. So we're just left over here with x plus 4. This side we did multiply by x minus 7. And then multiplying through by 8, you get 8x minus 56. And the rest of it is then easy to solve. Going to end up with 7x equals negative 7. 7x equals negative 60. X equals negative 60 over 7. Then you check that with the original equation to make sure it's right. Especially since I did a step in my head, you really want to check it. Okay? That's procedure. So a couple things you want to remember. First of all, well, in the assignment that's coming up, you're going to get well versed in how to use those rules. Okay. For commodity logs. And there's only basically a couple of them. If you add logs, you multiply. Okay. Subtract logs, you divide. That's just like adding. Okay. If you got a log of something to power, bring that power out into the log. Comes down to that, and it's not difficult. With practice, everybody's going to get it. Don't practice enough, and you're not going to get it as well. So make sure you practice enough. That's all the things standing between you and mastering that idea. Okay. Well, let's do another one. This. Okay, on the whole, it's doing pretty well with this. So we admit the fact that the x minus 3 is in parentheses. That might be hard to see where you're sitting. Okay, so this minus this is your log base 2 of this over this. That equals 4. Now, there's another thing you could do, and somebody kind of wanted to maybe do that. You could write the log base 2 of x minus 3 squared as 2 times the log base 2 of x minus 3 using the power. Okay, but that's not going to be helpful on this because you want a single log, and if you get the 2 out in front there, you're not going to have a, you're not going to be able to combine it into a single log. Okay, so this is the way you want to go, but both of those steps could be made. One of them leads you away from the ability to solve it. Okay. But they'd be valid steps. Just one of them would be helpful. Okay. So we have this, so we translate this to exponential form, which is going to tell us that x minus 3 squared over x plus 1 equals 2 to the 4th. Then we multiply by x plus 1. We don't bother writing the 1 as a denominator here. We write it as a denominator here just to remind us we're using fractions. But in any case, the x plus 1 is going to divide out. Okay. Here's the equation. We can expand the square. We're going to get x squared minus 6x plus 9. We can multiply this out, and we're going to get 16x plus 16. And I did see somebody get a 25. If that was you, yeah, you made a little error in the detail. You're going to subtract 16 from both sides. But how do we solve this equation? Okay, hang on a minute. Somebody's going to tell me I made a mistake. Okay, somebody misread my handwriting, thought I had a 4 there. I can see how that could be. Although I don't understand how anybody could misread my handwriting. But it's all right. I'll get over them. Okay, now, seriously, how do we solve this equation? Well, we have to recognize that this is not a linear equation. It's got x squared in it. It's got x squared, it's got x's, and it's got constant numbers, okay? Which means it's a quadratic equation, and we've got to put it into the form of a quadratic equation. But we want to put it into ax squared plus bx plus c equals 0 form because we don't know how to solve it otherwise. So we subtract 16x on both sides, which will give us a negative 22x here, and a 16, which gives us a negative 7 here. And now we have an equation we can easily solve using the quadratic form here, because you can tell looking at this thing that it's hopeless to try to factor. Okay. And I'm not going to take the time to simplify this. That's going to be 484. That's going to be 28, which will give you 512. Okay. 512 being the 9th power of 2, which is interesting, but that's not going to help us in the square root because it's an odd power of 2. It's actually going to be, what's going to be 16 times the square root of 2. But I'm not going to deal with that. Okay. You're going to try to simplify it. You're going to do it in the simplest possible form. You're going to get 11 plus or minus 8 square root of 2, I think. The point is, we go all the way from here to here, one step at a time. We combine the two logarithms so that we can change to exponential form. And then we solve that equation. First, multiplying both sides by the denominator. And then writing it out, identifying it after we expand the square as a quadratic equation because it's got squares in it, and so forth. Putting it into the standard form of the quadratic, well, that's kind of automatic, okay? Then use a quadratic formula. Make sense? It's not really particularly difficult, but you know, there are little tricks. So you do a lot of problems. Practice. Okay. Here's another one that you're going to love. It's not a logarithmic equation. There's kind of a trick on this one that you have to see. I'll give you a couple of minutes and see if anybody sees it, but I'm not going to let you stew over it for a long time. Okay, now as I said, I remember being stuck in one of these. Okay. Like today, I didn't like to be stuck. I really tried not to be stuck. I couldn't see what. And so it's probably why I couldn't see it. Okay. Now, first of all, you can't multiply the 5 by the 2 because then all of a sudden the 5 becomes a 5 to the x because or the 2. Okay. You can't do that. And you can't just throw a log in someplace. You could do the log of both sides. Okay. And I'll do that and show you how that works. I'm not using that in most of my problems. Okay. Although you've seen it done in open math. I'm doing one method that works. But you should pick up that other method too. I'd like to see it. But okay. Well, let's see. I can rewrite, well, divide both sides by 3 to the x. And I get 5 times 2/3 to the x. Well, all right, first is, well, that was, okay. I think my wrist was fine there. Okay. Well, I can write this as 5/1 times 2 to the x over 3 to the x. The numerator is still going to be 5 times 2 to the x, and 1 times 3 to the x is 3 to the x, and the denominator is still 3 to the x. So that works just fine. And then I can divide both sides. So again, I'll do it like this. 2 to the x over 3 to the x is 2/3 of the x. Okay. So now I just do I didn't write out the step, but I divide both sides by 5, and you should write out the step. Okay. And now I can solve it. Because now I have b to the x equals c, or b to the a equals c. X is log base 2/3 of 12/5. Now you're going to go to a calculator, and 12/5 is easy to convert. Going to get this. This is your exact solution, which I want to see. And then you take your calculator and approximate. So the only trick is you've got two different bases here. You can get it into this form just by getting both of these exponential expressions in the same slide. In this case, by division. Okay. That wasn't a great statement. So don't live by it. Get the idea. Okay. That's sometimes I was going to show you. Alternatively, take the log of both sides. Okay. Use properties of logs. This is log 5. Plus the log of 2 to the x. This is the log of 12 plus the log of 3 to the x. Okay. What's the log of 2 to the x? Now again, we're using the properties of logs that you haven't practiced a whole lot. Just kind of demonstrating them. And we'll probably do examples like this later, but you're going to see it in homework. Okay. Log of 2 to the x. The log of a power, you can bring the power out front. It's x times the log of 2. Well, and then that's going to equal log of 12 plus x times log of 3. Now you can solve for x. Subtract x log of 3 from both sides. You're going to get x log of 2 minus x log of 3. And subtract log of 5 from both sides. You get the log of 12 minus the log of 5. Okay. You factor out x over here. You have x times the log of 2 minus the log of 3. That's something you just use your calculator to get. That equals a log of 12/5. Because it's the log of 12 minus the log of 5. So that x equals log of 12/5 over the log of 2 minus the log of 3. Now, I went through that kind of fast, and this involves rules for logarithms that we talked about, but you haven't done a homework assignment on yet. So if you don't pick up every detail of that, it's okay. By the time you finish the next assignment, something like this will look very straightforward. It's a powerful technique. Okay. So don't worry too much about it if you don't understand it right now. But believe me, take a look at it after you've done the homework assignment. It should make pretty good sense to you. Okay, first of all, you got the log of something times something. That's going to be the log of the first something plus the log of the second something. Okay, so you can immediately apply this rule, and you don't even have to worry about the exponent. Now you can worry about the exponent. Okay, log of x to the 5th is just 5 log of x. Log of x y to the 7th is 7 times the log of 1. Make sense? Okay. Again, you're going to get used to it. I don't think you're going to find it difficult. How about this? You all doing? Okay, looks pretty good. Want to be careful though. Log of one thing divided by the other, just like the log of a product is the sum of the logs, the log of a quotient is the difference of the logs. Okay, so this would be like the log of a to the 4th, b to the 9th, minus the log of CQ. Okay, so you had log of this divided by this, and then you expanded this. And so it's, about 2/3 right, but the 1/3 where you divided was wrong. So when we expand this one, we're going to get the log of a to the 4th plus the log of b to the 9th minus the log of c cubed. And then we use the rule to get 4 log of a plus 9 log of b minus 3 log of c. Here we're going to graph y equals log base 2 of x. And it's the inverse of the exponential toolkit exponential function. -2, -1, 0, 1, 2, 4, 2, 1/4 exponential function 1/2 1, 2, 4. We flip the columns with the toolkit exponential function to get the columns as a toolkit logarithmic function. And then we need values of x, including 1, 2, and 4. We also need x equals 1/2 and x equals 1/4, which we can get easily enough. Now we have a familiar process. We start out with x equals 4. We can divide that in 2 and get x equals 2. Divide that in 2, we get x equals 1 every time we move twice as close to the y-axis, which is a whole lot like what we do when we take that 4x4 square. Except we're doing it horizontally what we did vertically. You don't have to understand it that way, but I think it'd be helpful to get fairly accurate graph. And then what y values do we need? Well, we just need -2, -1, 0, 1, 2. So we just put a bunch of equal spaced lines here. We're going to put y equals 2 here. Y equals 1 here. Y equals -1 here. Y equals -2 here. And we sketch ourselves the curve, which I didn't do very accurately. I'm high on that one. I kind of missed that one, but that's not surprising. Okay, there it is. Okay, we get a curve that looks much like this. We start at 1/4 -2. We end up at 2/4, 4/2, sorry. And we go through the x-axis at 0, at 1, 0. X-intercept is 1. I missed it. Did a bad job in the graph. There it is. Now, what if we wanted to graph? -2 log base 2 of x plus 3. How would we construct that graph? Now, what you want to do is identify vertical shifts, vertical stretches, horizontal shifts. Okay, first place, I'm just going to comment that this is y equals a f of x minus h plus k. F of x equals the log function, right? X equals log x. H equals -3. So that now f of x minus h is x minus -3, which is x plus 3. So we got the log base 2 of x. That h is going to give us a shift. A equals -2. And there's no k here. K equals 0. So make sure you understand this, because universally this is what gives you your reflections about the x-axis and vertical stretches and horizontal and vertical shifts. Now there are also horizontal compressions, and they can be included in the model. But we don't need them for this, at least at this point, okay? And you can deal with those as they occur. So what this tells us is vertical stretch factor is 2, and we reflect about the x-axis. At a horizontal shift of -3. X has been replaced by x plus 3, meaning you shift -3 units. And A equals 0, so there's no vertical shift. Not these, I'll have one to write on. So what we do is let's start with our toolkit log function, okay, which is the base 2 log. Now I'm going to put this in a 4x4 box. Bounded by x equals -2, or y equals -2, y equals 2, and x equals 4. It's kind of box for the exponential function turned over. And if you took the exponential function, turned the graph over like this, and then flipped it, you would have this, okay? But you don't need to know that. Doesn't hurt if you do. And I'm gonna, if I can find it, put a red dot. Need a little paint pen that shoots red dots. No, they won't let me bring a gun in here. Can't blame me. Okay. Sounds like we got a red dot here, just a reference. And this graph fits nicely in that red dot because the numbers that we got fit this process that you ought to be used to. So we have points here, 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 and here. Very much like the way we do the exponential function, toolkit exponential function. Just kind of turn on its side and one more little version. Okay. So what do we have to do? We have to stretch it vertically by factor 2 and then flip it over the x-axis. Well, if we're going to stretch it vertically, then y equals 2, it's really bad 2. Y equals 2, this point has to move twice as far from the x-axis. In other words, y equals 2 is going to be replaced by y equals 4. And y equals -2 is going to be replaced by y equals -4. Just to, you know, this is what happens if we vertically stretch these two horizontal lines. They move twice as far from the x-axis. And we're still on the line x equals 4, but now our top point will be up here. Our next point will be down here. Our next point will be here. Our next point will be here, and our next point will be on this line down here. And our graph would look like this. So this is the graph of y equals log base 2 of x. This one's vertically stretched. This is y equals 2 log base 2 of x. That was out of time. You just kind of quickly, but we can flip this graph over the x-axis. And we find that it looks a lot like this. So this would be y equals -2 log base 2 of x. Now all we have to do is horizontally shift it 3 units, -3 units. So we take our vertical asymptote, which is the y-axis. We shift this over 3 units. That's 4. This is about 3. So we should go over here to x equals -3. Now we just move every one of these points over. And we get a graph. Pretty much does. This would be our y equals -2 log base 2 of x plus. That'd be hard to read. Could have planned that better. Okay. Make sense? Okay, now on your homework, you're going to see graphs and you're going to be asked to interpret them. Okay, so I just constructed one for you. You'd be asked, they don't ask you to construct a lot of graphs because it's hard to do with a mouse and a computer. Okay, that's one shortcoming of the whole platform, and there's nothing they can do about it. But they show you a lot of graphs and ask you to find the equation. Okay, so you kind of work the idea backwards, and they'll give you some explanation how to do it. Now that assignment isn't due for another week, but I wanted to kind of introduce the idea. We'll talk more about it next time. Okay.